Hello students, how are you all? Welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. So students, here grade 8 IIT Foundation chemistry. Already we started the chapter atomic structure, right? And in this chapter we already started and discussed about the Dalton's atomic theory, right? Dalton's atomic theory and its drawbacks also we discussed, right? So today we are going to discuss about the J.J. Thomson's atomic model. So before going to that, first let's start with the J.J. Thomson's experiment, right student? Chalo. Now see here. Since here in the last class we discussed that Dalton's atomic theory states that atoms are indivisible, right? This was proved as wrong by J.J. Thomson by discovering the electron with his famous experiment, cathode ray discharge tube experiment, right? So what it is? It's a very simple experiment. So here by this experiment, J. Thomson disproved the Dalton's atomic theory and also discovered the electrons, right? So this experiment consists of a small glass tube. So you can see here, there's a glass tube which consists of two electrodes. One is called a cathode and the second is called anode. What's a cathode? An electrode which is connected to the negative terminal is called a cathode. An electron which is an electrode which is connected to the positive terminal is called the anode, right? So here you can see here, this electrode is connected to the negative terminal. Can you see here? Negative terminal. And this electrode is connected to the positive terminal. So the positively connected electrode is called anode and the negatively connected electrode is called cathode. And there is one vacuum pump. So this is a vacuum pump is fixed here to remove the air from the discharge tube to maintain a low pressure inside, right? When the pressure is maintained very low in terms of mercury barometer, you can say that 0.01 mm pressure. So when the pressure inside the tube is maintained, see how very low pressure, that is 0.01 mm of pressure is maintained, and here high voltage that's approximately 10 kilovolts, means what, 10,000 volts or above maintained. Then it was observed that a green color glow, can you see a green color glow is observed near the anode. Green color glow observed at the anode. So from where this glow has come? To explain this, J. Thomson said that from the cathode, some particles which are negatively charged particles, of course they are proved as negatively charged. Later how I'll explain in the properties. Okay. So here from the cathode, when the pressure is maintained 0.01 mm and voltage is maintained 10 kilovolts, then invisible particles, okay, which are called as a cathode rays, are emitted from the cathode and they travel straight towards the anode. They travel straight to the anode, and here when they struck to the fluorescent screen, then they causes the green glow at the cathode, at the anode. Clear? So in this way, J.J. Thomson discovered the cathode rays. Is this clear? Cathode rays. Okay. So this is the discovery of cathode rays. Now these cathode rays later they were named as electrons. They were named as what? Electrons. Right. So now let us see what are the properties of these cathode rays. Right. So see students here, properties of the cathode rays. Properties of the cathode rays. The first property what I said is that these cathode rays produced from the cathode and they're moving straight towards the anode. They move towards the anode in a straight line. So that's the first point. So here cathode rays are produced at the cathode. Where they are produced? At the cathode, and they travel towards the anode in a straight line. Okay, they travel towards the anode in the straight line. They travel in a straight line towards the anode. Okay, now how come you know these particles are negatively charged particle? Okay, so the second point is that these cathode rays are the negatively charged particle. How can you say these particles are negatively charged? So for this, what he did, so see here, this is a cathode ray tube. So once again, roughly I am drawing here. So this is a cathode ray tube, and here it is an anode, right? Here it is a cathode, right? This is connected to the negative terminal. This is connected to the positive terminal, right? So here, whatever the cathode rays are produced, these cathode rays travel in a straight line, okay, they towards the anode. So they travel in a straight line towards the anode. This already we have seen in the previous picture, previous slide, right? Now here what happened, what he did is, he arranged once again the positive charge at one side, means perpendicular to the discharge tube, and the negative charge on the other side. Means what? He arranged two plates perpendicular to the cathode ray tube, okay, perpendicular, and a positive and a negative. Electrons, means cathode rays are the negatively charged particles, already we discussed, right? And if there was no positive and negative charges here, then what would happen? The rays are traveling straight and striking to the anode, right? But now what I did here, he arranged the positive charge here and negative charge. Okay, two plates with positive and negative charges are arranged perpendicular to this one. Now does this travel move in a straight line? No. Why? Because here these are the negatively charged particles, and you know that like charges repel, unlike charges attracts, right? Like charges repel, unlike charges attracts, opposite charges attracts, like charges repel. You know, I think this one, right? So here, as these are the negatively charged particles, as the cathode rays are the negatively charged particles, they are attracted towards the positive charge because opposite charges. So opposite charges attracts. So now the negative charged particles are attracted towards the positive charge. Yes or no? So here they are attracting towards the positive charge. They are attracting towards the positive charge means what? These are the negatively charged particles. So in this way, the cathode rays, okay, so carries the negativity. It was okay, clear that cathode rays carries a negative charge. So here see, these particles are moving and striking towards the anode. Clear? And next one, this already we discussed here. Cathode rays travels in a straight line. Okay, cathode rays travel in a straight line. How can you say? Very simple. For example, if there is a path of light, you think you are standing in between the path of light. Means what? There is a light and there is a wall, and between the light and wall, if you stand between these two, then what happens? Then the light will strike to you as you're opaque. Then what happens? This your shadow, okay, will form behind this one. Okay, this says that light travels in a straight line, right? So here also J. Thomson arranged one metal cross here. Can you see a metal cross in the path of the cathode rays? So the cathode rays are passing straight and striking to the metal cross. As metal cross is opaque to the cathode rays, then what happens? The shadow will be cast on the behind the anode. So this shows that light travels in a straight line, right? Means cathode rays travels in a straight line. And then one more important thing is also there here. The property is when these rays strike to the metal cross here, and for some time, okay, and after some time, if you take out this one, then this metal cross becomes hot. So meaning is what? Cathode rays, okay, cathode rays produces heat, okay, produces heat. This is also one of the important point you need to remember, right? Then come to the next properties here. Electric field and magnetic fields are deflected by the cathode rays. Yes, already just have shown here, when you placed the positive charge, then they are deflecting towards the positive charge. This positive charge is what? It's a part of electric field, right? So cathode rays will be deflected by the electric field. Similarly, cathode rays also deflected by the magnetic field. Okay, for example, instead of the positive charge, for example, if you take the north and the south poles of the two magnets, if you arrange perpendicular to this path of the cathode rays, you will observe that these rays will be deflected. So the meaning is what? Magnetic field also deflect the cathode rays. So cathode rays will be deflected by both the electric and magnetic fields. Next, cathode rays possess momentum and kinetic energy. This is also important point. Cathode rays produces mechanical energy. Students, mechanical energy. What does it mean by the mechanical energy? For example, you see here, if there is a light is there, okay, the light in your home, in your house, you can see there is a light, and these light rays are traveling in all direction and falling on the walls, right? In the path of light, if you place any wheel, any light wheel, if you place, does this wheel rotate? No. Yes, the wheel cannot rotate. Means what? Light rays cannot able to rotate the wheel. The meaning is what? The light rays cannot produce a mechanical energy. But if we place one small wheel, can you see here the wheel? The wheel in the path of the cathode rays. When the cathode rays struck to this wheel, then what happens? Wheel start rotating. Wheel started rotating. The meaning is what? This cathode rays making to rotate the wheel. The meaning is that they are producing mechanical energy. So in other terms, you can say that cathode rays possess momentum. Why the momentum? Because momentum formula is what? Momentum formula is mass into velocity, the product of mass and velocity. You know that these particles has a mass. These are the particles. So they have the mass and they are traveling with some velocity. So they possess the momentum and the kinetic energy. Yes. Now, cathode rays produces heat. Already we discussed. Okay, cathode rays produces heat. Okay, and apart from this one more important nature of the cathode rays is that cathode rays produces the X-rays. Students, cathode rays produces the X-rays. Okay, so X-rays, you know the X-rays. Okay, whenever someone's bone fracture, then if you go to the doctor, they will diagnosis by using the X-rays. So X-ray picture can locate, okay, can diagnose exactly where the bone is located. That is the X-ray. So X-rays are produced from the cathode rays only. When the cathode rays are allowed to strike the hard metal plate or metal block. For example, here I am taking one metal block which is made up of tungsten. Okay, for example, which is made up of tungsten. Okay, then what happens? Then these rays, okay, strike to this one. Then what happens? These, after striking, okay, the secondary rays, this cathode rays, these are the cathode rays. After striking the tungsten, okay, they reflected. So these are called the secondary rays. These secondary rays are nothing but a X-rays. These secondary rays are nothing but a X-rays. So X-rays are produced from the cathode rays. Okay, so these are the important properties of the cathode rays. Okay, so students, here today we discussed about the discharge tube experiment, that is discovery of electron and the properties of the cathode rays. In the next class, we discuss about the E/m ratio of an electron. Okay, so with this we stop today. Bye.